Hello everyone, this is Adan from eAcademy, and today in this video we will be looking at dealing with missing data on known time series. This is the second episode of dealing with missing data because first part was actually an overview on how to deal with missing data, either to go with deletion or imputation. So this video is dedicated to the first part of deleting the missing data and unknown time series data. So before starting, you can follow me on Twitter as well as on other platforms like GitHub, Instagram, and Facebook. The link will be in the description, and this notebook will be available on my GitHub repo as well. And you can also subscribe this Academy to get notified on tips and tricks in the field of data science. So let's start with the reasons for missing values, because when we have a data, there are missing values. And the reason for having missing values, there are three common reasons. We'll say that the first is by default, there is no data or the data non-existential property. We can say that. And we can understand this. For example, in a survey, we ask people on the Academy that please write down their age and education in the comment section. And if someone of you declines to answer the question, that will result in a missing value for their age or education. So that's by default, there is no data or data non-existential property. The second one is when the data hasn't been collected. This is, for example, it could be due to human error as well as machine error. Let's say in a medical study, a patient's blood pressure reading may not have been taken due to equipment failure or due to some human error. And the third one is data deletion while storing. And it is very common because, for example, when we store some data of customer transaction in a database, and a record may have been accidentally deleted due to a software glitch. So there are three basic reasons for having a missing value in your dataset. So now we will be going through a dataset in Python. So we'll start it with some basic libraries. I have imported Pandas and Seaborn for data manipulation, and Seaborn here because I have to load the dataset that is by default in it. So that's a Titanic dataset. So let's load and import these libraries here. If these libraries are not installed, then you can also install by pip install command. So the data has been loaded here. We have different columns like survived, passenger class, sex, age, siblings, parents and children, fear, embarked, so on and so forth, right? So in this data, the target of this data is to predict the survival of each passenger based on all the other variables, right? So survival is actually a dependent variable and the rest are independent variables. But here the target is on the missing values. First, we have to see the missing values. We can see the missing values with the help of this command, that is df, the data frame is null, and we have to take the sum of the values, and it's better to sort them in descending order to see actually how many values are missing. So here we can see how many values are missing. We have 4 columns that have missing values. Tech has 688 missing values, age has 177, embarked and embarked town has 2 missing values. And also it is important to see the percentage of the missing values as well, because in research and other studies, we have a threshold based on the percentage. And whenever we have to delete a certain column or certain value, it's better to know the percentage to find out how significant it will impact our analysis. So here, after taking the percentage, DEC has 77.2% missing values. On the other hand, age has 19.86% values. Embarked and embarked towns have 0.2% of the missing values. So DEG is at the top with the 77% missing values, age more or less 20%, and embarked and embarked town are having 2% of the missing values. So at this stage, we know that there are 4 columns that have missing values. And if we want to visualize these missing values in our dataset, we will be visualizing it with the help of the library that is known as missing_no. And you can also install it with simple pip install command. And here I've imported it as MSNO. So now I have to plot a bar graph of all of the missing values in our dataset to find out the completeness of our data. So here is the plot of all of the missing values. We can see that DEC has the least number of values because more than 70% of the values are missing here, and age has 20% of the values are missing here. So here in the embarked and embarked town, only 2 values are missing. That's the 0.2% of the total data. So this graph is giving us the picture of completeness of the data. Now if we want to find out a pattern in the missing data, we have to look at the matrix for the missing values by the same missing_no library. And that will actually help us to see if there is a pattern between the missing values in each and every column. First of all, if we look at the embarked and the embarked down, there are two missing values. Now we can see that if there is a missing value in the embarked, there is also a missing value in the embarked down. Same goes for the second as well. So this implies that there is a relation between the missing values of the embarked and embarked down, as the name suggests as well. On the other hand, if we look at the age column and the deck column, then it doesn't seem to have a certain pattern between these two columns. We can also confirm it with the help of heat map. And this is a simple command, msno that heat map of that data frame. So here, embarked down, if we look at the embarked down, and here is the embarked, there is a correlation of 1. That's a very high correlation. But if we look at the age and the deck, the correlation is 0.1. And this heat map is actually in line with this missing value pattern, that there is no such a pattern in the missing values of age and deck. So that's why there is not a high correlation between these two variables. So far we have seen that how we can find the missing values, and how to find the percentage of the missing values as well, and how to visualize the missing values and see if there is any pattern between them with the help of missing low library. So the next step here is to find the state of the missing values. Is it the missing values are at random or the missing values are not at random? All of these things are really important before deciding if we have to delete or if we have to impute, and which method or technique actually we'll use in order to impute or delete a certain variable. The first thing is missing completely at random. Missing completely at random is also known as MCAR, which implies that the missing values of a certain variable is not actually dependent on any other variable of the dataset. And that's why it will not actually cause a certain biasness in the analysis. The second one is missing at random, that is known as MAR, and which implies that missing values of a certain variable will depend on one or more other variables in the dataset. But it will not depend on itself. It will only depend on the other variables of the dataset. And missing at random values are not be a part of a significant biases in the data. The third one is missing not at random, that is MNAR. When any value is missing not at random, which implies that the missing data is actually dependent on itself, and that will causes a significant biasness in the data. And now we'll see how these three approaches of being at random or not being at random will affect the technique of deletion, right? So in the previous video, we have seen that there are three main approaches of deletion. The first one is the pairwise approach, the second one is listwise or row approach, and the third one is the column approach. If we look at the pairwise approach, we can use pairwise approach if and only the data is MCAR, it is missing completely at random, and we only delete certain variables instead of deleting all rows and all columns. That's why it is a pairwise deletion. We only delete certain values, and this is only preferable when amount of missing data is really small. For example, the percentage of embarked in the embarked down is really small as compared to the rest of the missing data. So we can use the pairwise approach for this thing, right? So for this, what we can do, we can simply use df and drop na. We have to drop the null values from which column. We can define a subset of the two variables on which we have to imply the pairwise deletion, and here in place is equal to true, which means that we have to update our data frame. So if we execute them, and now to see if it works or not, so here embarked and embarked down are all pairwise deleted, and there is no null value in this embarked and embarked down. So we have used pairwise deletion. If we move further, the next approach is listwise deletion. And again, the listwise deletion will work when you have a data that is missing completely at random. And listwise deletion is not really recommendable because here we delete all of the dataset that has missing values. And if you are doing so, there should be a reason and that have a significant impact on the analysis that you are doing. If you are going with the row-wise deletion or the list-wise deletion, then you can have df.dropna, dropping all of the null values, and then you have to update in the dataset and checking it with this command, all the null values has been deleted with the list-wise deletion, right? The third approach is to use column deletion, and in this actually we have to delete a certain column that have a lot of missing values, because here the deck column has more than 70%. So the threshold could be different at your end, or it could be different according to the question that you are dealing with. But if the column that has a missing value and it exceeds 70%, then it's better to delete a certain column unless or until that deletion has a significant impact on your analysis. So if you want to delete a certain column, then we can have df.drop, and we have to specify the column name and then update the data frame in order to see if it works or not. Let's see df.columns. There is no deck column here and it has been deleted. Again, deletion approaches are not actually recommendable unless the data has a very least missing values, or deleting the missing values have a significant impact on your analysis. And in the next video, we will see how we can impute the missing values in a dataset, on which techniques, and when to use advanced and when to use general techniques. So we'll meet in the next video. Till then, take care. Goodbye.